Next, we consider rules for limits, and these help us to calculate limits, and basically they allow us to rewrite limits in a more convenient form. Okay, so let's start off with one of these. Supposing that you know that the limit as x goes to x naught of x is equal to L. F is some function. And now there's a new function, c times f, where c is some real number. And then the rule is that the limit as x goes to x naught of cf of x is equal to c times L. So basically what that means is that you can pull a constant multiple outside of the limit sign. So let's see an example of this. F sends reals to reals is such that the limit as x goes to 7 of f of x is equal to pi. Okay, now what is the limit as x goes to 7 of 3 times f of x? Well, the rule says that we can calculate it like this. The limit as x goes to 7 of 3f of x, 3 is a constant multiple. You're allowed to pull it outside of the limit sign. It's 3 times the limit as x goes to 7 of f of x. We said that that limit was pi, so this is equal to 3 times pi. Okay. Now, supposing that you have functions f and a function f which has a limit L at x naught, and we have a function g which has a limit m at x naught. Now, the limit of the new function f plus g will be L plus m. And the limit of the difference f minus g will be L minus m at x naught. Okay, so the limit of the sum is the sum of the limits, provided that the individual limits of the two individual functions exist. And the limit of the difference of functions is the difference of the limits of the individual functions, provided that the limits of the individual functions exist at x naught. Okay, so let's take a look at this. The limit as x goes to 1 of x minus 1 over x minus 1 plus x squared. That's a limit of a sum of functions. So if the limits of the individual functions exist, that's the limit as x goes to 1 of the first function, plus the limit as x goes to 1 of the second function. Okay. Now, the limit as x goes to 1 of 1 and the limit of x squared, and both as they go to 1 is 1. 1 plus 1 gives us 2. Okay. The limits of the product of functions, supposing that the f has a limit L at x naught and g has a limit m at x naught, then the limit of f times g at x naught is equal to L times m. So the limit of a product of functions is the product of the individual limits, provided that the individual limits exist. Okay, so let's look at this one. The limit as x goes to x naught of 3x to the fourth plus 2x squared plus 7. So first of all, it's a sum of functions. So we can split it up as the limit of the first function plus the limit of the second function plus the limit of the third function. The first function has a scalar multiple, so we can pull that scalar multiple outside. The second one does also. The third one's a constant. That'll be easy to do. Okay, now the limit as x goes to x naught of x to the fourth. Well, as x gets really, really close to x naught, x to the fourth gets really, really close to x naught to the fourth. As x gets really close to x naught, x squared gets really close to x naught squared. And as x gets really close to x naught, 7 is arbitrarily close to 7. So we get 3x naught to the fourth plus 2x naught squared plus 7. So these rules allow us to break up and to manipulate the limits of a function, and we can take a more complicated function and break it up into, take limits of smaller pieces. Okay, for quotients, we always have to be a little bit careful. If the limit of f is L and the limit of g is m, which is not equal to 0, then the limit is x goes to x naught of f of g of x. F over g of x is equal to L over m. So the limit of a quotient is the quotient of the individual limits, provided that the denominator function is not going to 0 as x goes to x naught. Okay, so let's look at this one. Limit as x goes to 1 of 1 plus x over 1 plus x squared. How do we do that? Well, the limit of the quotient is the quotient of the limits. And, well, 1 plus x as x goes to 1 gets really close to 1 plus 1. And 1 plus x squared as x gets really close to 1 gets close to 1 plus 1 squared. And that gives us 2/3. We have composition of functions. Supposing the limit as x goes to x naught of f of x is equal to L, and the limit as y goes to L of g of y is equal to g of L, then the limit of g as x goes to x naught of g composed with f of x is equal to g of L. Okay, so as an example, we have a sine function composed with a polynomial function. Okay, and so then we can take that as the sine of the limit as x goes to 0 of pi plus x squared, which is sine of pi, which is 0. Okay, so those were some rules for how we can take limits of complicated functions and break them down into limits of simpler functions.